Okay, we are going to have a look at 3 ways why 0 factorial is equal to 1. The first way we're going to do it is via a pattern. So I'm going to write down 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial, and 5 factorial. Okay, so remember, 5 factorial is 5 times 4 times 3 times 2 times 1. So there would be 120 possibilities of arranging 5 things in a line. 4 factorial would be 4 times 3 times 2 times 1. So that's 24. 3 factorial would be 3 times 2 times 1. 2 factorial, 2 times 1. 1 factorial, 1 times 1. Is there a pattern? Well, of course there is a pattern. Let's have a look. To get from here to here, we have divided by 5. From here to here, we've divided by 4. From here to here, we've divided by 3. From here to here, we've divided by 2. So if we continue this pattern, we would divide by 1. Okay, so we'd think, okay, what's 1 divided by 1? 1. Therefore, 0 factorial equals 1. That's way number 1. Way number 2 is that we could rethink about how we could explain what factorials are. It's almost using this, but not using a pattern, it's more formalising it. If we think about 4 factorial, 4 factorial we're going to write as 5 factorial divided by 5. Remember, that's kind of what we did here. To get 4 factorial, which is 4 times 3 times 2 times 1, well, we could have worked out 4 factorial from 5 factorial knowing this pattern. Okay, so 4 factorial is 5 factorial over 5, so that's 5 times 4 times 3 times 2 times 1 over 5, which is 120 over 5, which is 24. And we can kind of just get that from the table above as well. Same sort of thinking, we could rethink 3 factorial as 4 factorial over 4. 4 factorial over 4 gives us a 6, excuse me. 4 factorial over 4 gives us 6. 2 factorial we could think of as 3 factorial over 3. 3 times 2 times 1, that's 6 over 3, which is 2. 1 factorial we could think of as 2 factorial over 2. 2 times 1 over 2, 1 factorial is 1. But if we then therefore define 0 factorial as 1 factorial over 1, well, that's going to be 1 over 1, which is 1. Therefore, 0 factorial is equal to 1. That's way number 2. Way number 3 is almost like a... Wait, let's label these. This is way number 1. This is way number 2. Similarly, way number 3. Let's think about if we've got 3 objects. A black dot, a red dot, and a blue dot. If we wanted to arrange those 3 objects, we could have black, red, blue, black, blue, red. I'm actually going to do this with letters. This is going to take forever changing my colours here. Let's go with letters. There we go. Let's imagine we've got 3 letters. A, B, C. Well, we've got, how many ways can we organise that? We could get A, B, C, C, B, A, B, A, C, B, C, A, C, A, B, C, B, A, C, B, A. Okay. So that is if we had 3 letters. What if we had 2 letters? We've got AB or BA. So from there we could say 3 factorial is 3 times 2 times 1, which is 6. Here we've got 2 factorial, which is 2 ways. If we've just got 1 object, well, there's only 1 way to arrange that. 1 factorial is 1. But see if we've got no objects, there's only 1 way to arrange that. Okay, so there's only 1 way that we can have 0 objects, and it'll be this way here where there's nothing there. That's the one way of how we could arrange it. Therefore, 0 factorial is equal to 1. There is your third proof, and there are 3 ways as to explain why 0 factorial is equal to 1.